All right, let's go back to this side, and we're going how many variables. What if we want to do the relationship between more than two variables? And it says regression, factor analysis, etc. I'm going to do regression example. Right? I wish you could see my how I do the menus, but I'm going to go analyze, regression, and I'm going to go linear regression. Lots of choices here. There's lots of complicated ideas. All right. TPCK is technological pedagogical content knowledge. And theoretically, I would say that that should be related not just to technological knowledge, not just to content, not just to pedagogy, but to the relationship between those things. So two variables I would think it's related to is technological content knowledge and pedagogical content knowledge, right? It's kind of like the combination of those two things. So it's not just one of them, it's more than one. So I could actually put all the other average variables in here. But I'll just say, thinking logically, these might be the two that would be most representative of all the others, and my TPCK should relate to both of these together. So the regression allows me to do relationships between variables, but more than two at a time. So I say okay, and this is really getting ahead, so we're going to look at this later. But you see these numbers here, the 0.72, allows us to look at those two combined and their influence on TPCK. And if I look down here, I can see how each one individually is affecting. And notice the sum is kind of less than each one individually, but because there's some interaction there. But both TCK and PCK are having an influence on TPCK together, and that's why regression would make sense in that case. All right, back to our map here. So we've gone down this side between variables with more than two. We've gone down this side, participants being tested more than once, comparing pre and post. We don't actually have anything in Ollie's data set. I don't think that, I'll have to think about that, but I'm going to skip this one. But I could also look at Ollie's data set differently. Instead of looking at the repeated measures part of it, I could just look at the post-test. All right, pretend he never did the pre-test. Just look at the post-test and compare groups on the post-test. So I could compare groups by semesters. I could compare semester 1 to semester 2, which would be a two-group test, and I would use the t-test. Or I could compare semesters 1, 2, 3, 4, and 5, whatever, between all those groups, each group being separately considered, and how it is semester 1 compared to 2 compared to 3. That's more than two groups, and that's simple analysis of variance, or ANOVA. Right? So I'm going to do the t-test independent samples first. So I'm going to go analyze, compare means, independent samples, as opposed to paired samples where you're looking at the same person paired. These are independent samples. People in semester 1 had nothing to do with people in semester 2. I mean, they're different people. All right, so I'm going to use semester as my grouping variable. And with the t-test, I have to define this. Which ones are they? I'm going to compare semester 1 to semester 5. I'm just picking 2 now. And I want to pick the most important variable here. And remember, I'm not doing pre and post, I'm just doing post. So I'm going to look at the most important variable, TPCK-A. And, hey, look at that. Notice this, the average in semester 5 is 4. The average in semester 1 was 3.5. So those are averages. I'm comparing the average of the group. That's why I'm on the right side of Salkind. And I do get statistical significance. Oh, right here. And it's showing me two different ways of representing the data, whether or not I'm assuming the variances are equal or whether I'm assuming they're not. It's an assumption that's made as a start of the test. Either way, I get p less than 0.05. All right, so that was the t-test. I'm on the, right there. But now what if I mean, I got more than 2 semesters. What if I want to compare them all? Then I use analysis of variance. Okay, so again, I'm going analyze, compare means, because it's the means for each of those groups. And there's a one-way ANOVA as one of my options. Here, the factor is semester, and that's going to do them all. Now, I'm not saying 1 versus 5. I'm just saying compare them all. And the dependent list, I'm just going to take, again, this variable here and run it. And in this case, I still found significance p less than 0.05. Right. Let me run that analysis one more time, because I think I want to include my descriptive statistics, because I always like to see those to help me understand if I'm looking at the data correctly. All right, so when I include the descriptives, it'll give me the mean and the standard deviation for each group. And I can kind of look to see if there really are big differences there, and that helps me understand if I'm looking at this number correctly and why it might make sense. Now, notice that it's just giving me one answer here. P is less than 0.05. These semesters are different. So this ANOVA test, and we're going to learn about this later, this ANOVA test is really just saying, are the 5 different? Not is 2 different than 5 and 3 different from 4. We don't know that yet, but we just know the 5 are different. So what we've done here is not looking at more than one testing, just looking at the post-test only, looking at more than 2 groups, simple analysis of variance. Hope that helps you make some connections. There's lots of ways of looking at Ollie's data set where you can go in these branches in lots of different ways. So I encourage you to just explore like that and think if you can make the connection between Salkind's figure and Ollie's data set.